This is Draw My Maths, and today we'll be talking about probability. So what is probability?
A probability is a measure of the likelihood that an event in the future will happen.
If x equals to even and px equals probability of event happening, if probability equals to 1, it means it's guaranteed. If probability equals to 0, it means it's impossible. If probability is closer to 0, it means it's less likely to happen. If probability is closer to 1, it means it's more likely to happen.
Now we can deduce that the probability formula equals to number of outcomes of x over the total number of outcomes. Moving on, let's talk about the rules of probability. So the complement rule usually refers to the complementary event of the probability that an event doesn't occur. So we can deduce that PA equals to 1 minus PA complementary. The general rule of addition says to find the probability of A or B happening, add their probabilities, then subtract the overlap. P or A or B equals PA plus PB minus PA and B. Thirdly, the special rule of addition. If two events can't happen at the same time, they are mutually exclusive. So just add their probabilities. First, PA or B equals to PA plus PB. Conditional probability is the probability of particular event occurring given that the other event has occurred. Is PA and B divided by PB written as P of A given B. This is the general rule of multiplication. Joint probability is the chance of A and B both happening, PA and B, while Bayes' theorem fits this to find that the probability of A given B equals to the probability of B given A times the probability of A divided by the probability of B.
Probability distribution is a listing of all outcomes of an experiment and the probability of each outcomes. There are two types of probability distribution. They are discrete and continuous.
Moving on.
So this is binomial probability distribution. Okay, so here is 52 parts. So what is the probability that you get heart, you draw a heart inside? So we know that 52 cards. So we find out how many hearts is inside. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so we know that we have 13 cards. 13 cards here, okay, is hearts. Okay, so the probability that you will draw a card in 52 cards is 1 on 4.
Possible outcomes plus how likely each one is. Blackjack just makes it fun.
Discrete probability distribution requires only a certain number of separate values and is usually the result of counting something.
There are three main features of discrete probability distribution. First, sum of the probability of all outcomes is 1. Second, probability of particular outcome is between 0 and 1. Third, outcomes are mutually exclusive.
There are two types of discrete probability distribution. They are binomial and Poisson.
Now let's take a look at what is binomial probability distribution.
Okay, so times.
There are four characteristics of binomial probability distribution. First, there can only be two possible outcomes. Second, the random variable is the result of counts. Third, probability of success remains the same for every trial. Fourth, each trial is independent.
So moving on.
Now let's look at binomial probability formula. The formula is given below where C equal combination, N equal number of trials, X equal value of number of success, and pi equal probability of success of each trial. Now let's look at Poisson probability distribution. It is number of times some event occurs during a specific interval. Interval can be time, distance, area, or
This is the Poisson probability formula. The formula is given below, where mean equals to mean number of success in a particular interval, E equals exponential, and X equals to number of success. Now let's talk about the steps in answering probability questions. Step 1. Define the random variable X. Step 2. State the type of probability distribution involved. For example, binomial and Poisson. Question. A badminton player wins a point on her serve 60% of the time. If she serves 5 times, what is the probability of her winning exactly 3 times? Solution. X equals the number of serve the player wins out of 5. The type of probability here is binomial. N equals to 5, X equals to 3, P equals 0.6, and Q equals to 1 minus 0.6. Then, we write out the binomial formula according to our data. The answer we get is 0.3456.
Now let's move on to continuous probability distribution. Here's an example. Now let's talk about the differences between discrete and continuous probability. Discrete probability needs to have a specific countable value, while continuous can be of any value within a range. Discrete usually uses a bar chart to represent, while a continuous uses a smooth curve. For probability in discrete, you usually just add the probabilities, while in continuous, you usually just find the area under the curve. Discrete consists of common distributions like binomial, Poisson, and multinomial, while continuous consists of normal, student, and uniform. Now let's talk about normal distribution. Normal distribution is most commonly known as Gaussian distribution. It is also a bell-shaped probability distribution and is symmetric about the mean. The formula below represents the probability density function. Moving on, there are 4 types of characteristics of the normal distribution. Firstly, is a bell-shaped graph where the mean will equals to median and it will equals to mode. Secondly, it is symmetrical about the mean. A normal distribution can be divided into 2 equal halves and these halves possess exactly the same shape. Thirdly, it is asymptotic, that is, the tails of the curve approach the x-axis but never actually touch it. Last and foremost, the normal distribution is completely described by its mean and standard deviation. Moving on to standard normal distribution.
Lastly, let's talk about standard normal distribution. A standard normal distribution has mean equals to 0 and standard deviation equals to 1. It is also called a Z distribution. Any normal probability distribution can be converted into a standard normal probability distribution. The formula for standardized value is given as x minus mean divided by the standard deviation.
And that's the end of our presentation, and that's all on our take on the probability distribution chapter.